Welcome back. Here is Centaurus, and these are the two bright stars of Centaurus here, Alpha and Beta. In star designations, the brightest star is given the term Alpha, and the next brightest, Beta, the next brightest, Gamma, the next brightest, Delta, the next brightest, Epsilon, etc. If you did that calculation, you found out that Alpha Centauri, 4.3 light years away, takes an awfully long time to get there, doesn't it? Now, what about these two stars here? Well, Alpha Centauri, right here, is 4.3 light years away from us. It looks like Beta Centauri is very close to it, but in reality, Beta Centauri is 350 light years away. And so these stars only look close to each other from our vantage point here on the Earth. In 2014, I was off the coast of Peru on a ship, and the Southern Cross was out. And when you get to the Southern Hemisphere, if you're from the Northern Hemisphere, to see the Southern Cross, it's quite a thrill. And here is Alpha and Beta Centauri. The problem with taking a photograph on a ship, of course, is that it's moving and it's bobbing up and down, and hence you can see here a bit of distortion in the stars themselves, but you get the idea of the relative positions. Quite often on charts you'll see constellations within a certain area, and notice that Centaurus completely surrounds the constellation Crux. Here is Alpha Centauri, and in reality, what is Alpha Centauri? It's not just a single star. It's at least a binary star, and the two primary stars are known as Alpha Centauri A and Alpha Centauri B. This was taken over top of the rim, the ridge, the rings of Saturn. And here is Alpha Centauri A and Alpha Centauri B. These two stars are fairly close to each other. They revolve around each other. They're separated by about a distance of about 5 billion kilometers, which is about the same as going from the Sun out to Neptune. These two stars, from our point of view, are very close together, and so we essentially see them only as one. We can't really see both the stars, but you'll see in a lesson that follows that stars are identified as being spectroscopic binary stars because one can use a spectroscope to reveal the presence of two or indeed sometimes three stars that are very, very close together. There is a third star that is believed to be associated with Alpha Centauri. Here's Alpha Centauri, here's Beta Centauri, and right down here is a third star known as Proxima Centauri. And it's considered to be part of the Alpha Centauri system because it's believed to be gravitationally attracted to this, and it would revolve around Alpha Centauri. Now Proxima Centauri, that little tiny star, it's a brown dwarf star. It's the closest star to us, but we can't see it. It's about 4.22 light years away. And you can see Alpha Centauri and Beta Centauri, but you certainly cannot see with ease Proxima Centauri. Now, what about Beta Centauri? Well, it itself is a triple star system. It has two large stars orbiting each other, separated only by about 600 million kilometers. And each of these two stars is about 15 times larger than the Sun. Now, what's going to happen to them is that in time, they will expand, turn into red supergiants, and then into supernova. We'll hear more about those concepts later on in the course. Then there's a third star associated with these two that's 5 times larger than our Sun. And it orbits around Beta Centauri every 225 years or so. So here's Alpha Centauri, Beta Centauri, and Crux. Now, what are our nearest neighbors? Well, the next nearest star to us after Alpha Centauri is Barnard star, and it's at a distance of about 6 light years. Wolf is known as a star to be next closest to Barnard, and it's 8 light years away. That's Barnard's star. It's a brown dwarf. So it is important to understand that distances in space are absolutely overwhelming. Distances are great. Things are a long, long, long way away from us. Now, all of the stars that we can see at night belong to one small unit of the universe, and that small unit of the universe, we can see portions of it because we are within it. And quite often we can see this band of stars, milky white in color, and hence the name the Milky Way galaxy. That is our galaxy. Our sun and all of our planets are part of this Milky Way galaxy. And every star that you see in the night sky, without exception, belongs to the Milky Way galaxy. We cannot see stars from any other galaxy. There's about an estimate of 200 billion to 250 billion stars that make up the Milky Way galaxy. That is one huge number. Now, if we were able to look at the Milky Way galaxy from outside of it, it would probably look like this. It's a spiral galaxy, much longer than it is thick. It has a central core consisting of old, bright stars, and in the very center of that there's a black hole, but more about that later. So we live in a beautiful spiral galaxy. From here to here, about 110,000 light years. So its diameter is about 110,000 light years. Its thickness, about 15,000 light years. So if you were to turn this on its edge and look at it from the side, even more so than that, it would be about 15,000 light years thick. Our solar system is right out here. It's in what's called the Orion Arm. See these spiraling parts of the Milky Way galaxy? Those are called arms. Now, beyond the Milky Way, there are other galaxies. And these galaxies are separated by absolutely massive distances. This is known as the Hubble Deep Field photograph. And literally, if you held out a grain of salt at arm's length up to the darkest portion of the night sky, that's how much area would be covered by this photograph. And it contains hundreds, if not thousands, of beautiful galaxies. There are a couple of stars here. This is a star here from our Milky Way galaxy. This is a star here. But the rest of these dots and colors and spirals are all galaxies, each containing hundreds of billions of stars. The nearest spiral galaxy to us, not the nearest galaxy, but the nearest spiral galaxy to us is the Andromeda Galaxy, at about 2.5 million light years away. It is the only spiral galaxy that we can see with our naked eye. And that is the Andromeda Galaxy. Isn't that beautiful? Again, notice that it's much wider, greater diameter than thickness. When you look at that, you can't help but wonder how much life lives in that galaxy. I mean, how much life lives in our galaxy, but that's another topic for another day. Here's the Andromeda Galaxy. Now, why is it called the Andromeda Galaxy? Because it's close to the Andromeda constellation. And the Andromeda constellation, we'll see in lesson 3, is hooked on to Pegasus. But here's where the Andromeda Galaxy is, and it's so called just because it's close to the Andromeda constellation. If it was, let's say, over here in Perseus, it would be called the Perseus Galaxy. Here's a beautiful photo taken by Christiane Fattinanzi off the coast of Italy. And can you see the constellation Andromeda? And then above it, can you see the Andromeda Galaxy? There's the constellation. And now look just above the middle of it. Can you see that little smidge? And that's the Andromeda Galaxy. And that's the only spiral galaxy that we can see with our naked eye. There are other galaxies that are closer to the Milky Way than the Andromeda Galaxy. The nearest galaxy to us is called the Large Magellanic Cloud, and it's a cluster of stars. It's 163,000 light years away. This is it here. That's the Large Magellanic Galaxy. And it was observed and noted by Magellan and his crew as they circumnavigated the world back in the 1600s. There's the Boötes Galaxy. The Small Magellanic Cloud. Did I say 1600s? I meant the 1500s. Magellan's crew circumnavigated the world in the 1500s. Anyway, the Small Magellanic Cloud is about 206,000 light years away. The Draco Dwarf Galaxy, about 258,000 light years away, found near the constellation Draco, the dragon. Again, it's a cluster of stars. It hasn't taken a spiral shape. So these nearest galaxies are not spiral galaxies, they're clusters. They could be called elliptical. NGC, New General Catalog, 2419 galaxy is 275,000 light years away. And other galaxies have more interesting names. You may have heard of the Crab Nebula Galaxy. This is it here. You may have heard of the Sombrero Galaxy. And you may have heard of the Cigar Galaxy, so named because of its shape. All told, there are about 250 billion galaxies in the universe. It's a huge number. And interestingly enough, the average number of stars per galaxy is about 250 billion. So if you take those two numbers together, 250 billion stars per galaxy multiplied by 250 billion galaxies, you end up with an awful lot of stars. How many stars are in the universe? What's the estimate? About that many. Hundreds, thousands, millions, billions, trillions, quadrillions, quintillions, sextillions. 62.5 sextillion stars. 6.25 times 10 to the power of 22 stars. That's a lot of stars. Now, that number is overwhelming. And if you are in any way enamored by that number, there's a really interesting calculation. It's called the freight train full of stars analogy. One analogy we used in high school was, if you imagine a star to be the size of a pea, how much volume would that occupy? Well, here's a more interesting one. Imagine you went to a beach, and the beach was sort of coarse-grained. And as you picked out grains of sand, you put them into a little container, and you found out that about 1,000 pieces of this coarse beach sand would occupy 1 cubic centimeter. Based upon that number, how much volume would all of the stars in the universe occupy if each star was represented by a grain of sand? Now, take it one step further. Imagine you were at a railway crossing and a train passed by containing nothing but grains of sand, where each grain of sand represented a star. And the train passes at the rate of 1 star per second. How long would it take for that train to pass you by if each car was filled with grains of sand, where each grain of sand represented a star? That is an interesting calculation. If you want to see the answer, here it is. If you want to work it out yourself, go back to here, work out the calculation, and see what answer you get. Go ahead. You'll enjoy it. Now, 1,000 grains of sand occupy a cubic centimeter. What is a cubic meter? Well, a cubic meter measures 1 meter by 1 meter by 1 meter in all 3 dimensions. In other words, 100 centimeters by 100 centimeters by 100 centimeters. 100 to the power of 3, or 100 cubed, is a million. So a cubic meter contains 1,000,000 cubic centimeters. each cubic centimeter contains 1,000 grains of sand. Therefore, each cubic millimeter contains 1,000 million grains of sand, or a billion grains of sand. Okay so far? Now, a freight train boxcar measures 18 meters long by 3 meters wide by 4 meters high. So what's the volume of a boxcar? 216 cubic meters. 18 times 3 times 4. That means each boxcar train could hold 216 times 1 billion grains of sand, or 216 billion grains of sand. How many grains of sand are there in the universe, as represented where 1 grain of sand equals a star? 62.5 sextillion. So divide the number of grains of sand per boxcar into the number of grains of sand in the universe. And what number do you get? Here's the number of boxcars that would be filled. 289,300,000,000 cars. Now, if each car passes by at the rate of 1 car per second, it's going to take you 289,300,000,000 seconds for that train to pass. Well, how long is 289,300,000,000 seconds? How many minutes would that be? 4 billion minutes. How many hours would that be? 80 million hours. How many days would that be? 3 million days. How many years would that be? 9,000 years. You'd be at that railway crossing waiting for 9,000 years. Now, isn't that an amazing number? You'd be there for 92 centuries. So it just gives you some idea as to how many stars are out there. And earlier we looked at the vast distances of space. So after you've moved past the last galaxy, what is out there? Absolutely nothing. Everything that exists is found within the universe. There is nothing beyond the universe. And the edge of the universe is about 13 billion light years away from us. We're part of the Virgo supercluster, and if we go out in either direction, 13 billion light years, you'd come to the edge of the universe, if you could ever come to the edge of the universe. Now, the edge of the universe rather, has been expanding ever since the Big Bang, which occurred about 15 billion years ago. This is an image that represents all of the galaxies, but each one of these dark spots on the image represents a supercluster of galaxies. And that's what our entire universe is supposed to look like. It is an amazing wonder to behold. Our universe contains a tremendously great variety of objects, stars, nebula, constellations, galaxies. And some physicists have said and remarked the fact that the universe is wilder and weirder than you could ever possibly imagine. Welcome to astronomy, and thank you for working through lesson number 1 with me, the night sky.